Welcome to Cyber Profits. In this brand new episode, we're going to talk about a very interesting topic, the topic of data science. Remember, Cyber Profits is a podcast made for you and for you only in order to be prepared for the future. My name is Edgar Regalado, and I'm here with my co-host, Federico.
Welcome, everyone. Hopefully today we're going to get new insights about data science and uncover some of the secrets about this important area.
In our quest for finding professionals in very specific topics such as data science, we came across a very interesting profile, the profile of another woman who works in STEM. She is currently employed as a researcher at Innopolis, the Russian Silicon Valley. Remember, we already interviewed Xavier from Innopolis as well, and Hamza. She's working on the application of statistical methods to software engineering data and the categorization of system processes, such as user activities. Also, she has experience in the area of computer vision, and she has also some projects related to the text processing and music identification. People, let's give a very warm welcome to our guest of the day, Zamira Kholmatova. Zamira, welcome to the show.
Thank you very much, guys. Thank you. My name is Zamira Kholmatova. Yes, I'm working as a researcher at Innopolis University. Yes, and we are working on a system that is aimed to collect the data from the developers related to the software development processes, like lines of code, to the code itself, and, for example, a lot of data related to the process entities they used. Yes, process activities. For example, which activity is it, how long they used it, users, and, for example, which operating system they used, and some kind of data that is possible to extract from the session.
Wow, that's incredible, Zamira. And so we now know what you're doing right now, that you're working as a researcher and trying to get your PhD at Innopolis University. But could you tell us a bit more about your experience? What is your background? What have you done in your past, etc.?
Well, first of all, I have my bachelor degree in mathematics. So I was studying math, and I was doing some application of statistical methods to medical data from the beginning. It was interesting for a while, because you take the famous statistical techniques, you take the medical data and try to apply these techniques to this data. And for me, it was not so interesting, maybe, or it was not interesting maybe because I was not so familiar with medicine. So you have this data, yes, and you cannot interpret it because you need some background knowledge to know how it works or something else.
Yes, exactly.
Yes. After it, I decided to improve my statistical knowledge, to improve my practical part, how to construct the data extraction mechanisms, how to apply more complicated models, more popular, more complex, how to use them. Yes, and I decided to have a degree in computer science.
Nice.
Yes, and since this moment, I had a lot of projects related to the application of statistical methods, machine learning techniques, to this kind of data, to that kind of data, to text processing, to music generation, and it was amazing. One of my first projects was in computer vision. For me, it was really interesting. It was my first experience. We had a small data set with numbers, with handwritten numbers. Maybe, you have old houses, old buildings, yes, and you have the handwritten numbers on each building. That, for example, some people wrote or something else. And in order to differentiate them or to somehow know what is the number, we needed to construct the classification mechanism. And what to do if we have a small data set? For example, we have not so many data, but we need to learn on it and somehow to test. But the data was really in a small amount. So we decided to make something different. It's called domain adaptation. When you have more or less similar data set available in somewhere in the internet, in some competitions, right? The open source data sets with a huge amount of available data, with a huge amount of handwritten photos, for example, photos, how different digits, different numbers with labels. And you can learn on these data. And then after learning on these data or predefined the huge amount of data, you can transfer this model to your data. Because it's more or less similar. And you can gain some knowledge of your model that learned on your huge data set. So it was my first project. The second interesting project was with text classifications. Yes, we just tried to know if this sentence has negative, how can I say, meaning or positive meaning. Is this comment? Yes, it's just a toy example, but it was really interesting how to pre-process, how to work with them. And text classification is still one of the most interesting topics for me, because there are a lot of to do and you can do whatever you want. One of the most difficult projects then I worked was the project related to the music. We did with a group mate something like Shazam. Yes.
Okay. Yes.
We were trying to find the music that was playing, yes, and then to put this music, if we found it, we found it in our database. If we didn't found it, so we just try to, how can I say, make label for it and add to our data set till we can find it again.
I see.
Yeah, something like this. And it was difficult because it was the approach to music preprocessing is not so popular. Yes, and it's has some difficulties because you need to cut in that place and see how many seconds there really looks similar. And for example, if you have some mix of this music, it's another story. It's just you cannot find the similar, yes, and you have the same, almost the same music, but because one of these has some mixes, some additional buses, for example. Yeah, so you can't tell that they're the same.
It sounds like a very, very, how to define it, incredible projects that I had not even idea how did you move forward. And the one about the music sounds like another level. Creating your own Shazam is like something completely unexpected. But now I would like that maybe you could help us define what is data science, but thinking like for a non-technical person, how would you speak to, let's say, to a child? What is data science?
For me, data science, like a term, is very broad. Yes, because for example, you can see some advertisement. For example, we are looking for a data scientist, and what he needs to do. Yes, and there's specific like they are hiring the whole IT department of the big companies. Yes, for me, for example, the data science it's something is combination of computer science, mathematical sciences, and business needs.
Oh,
The intersection of these three components, it's for me a data science itself.
okay. So computer science, business, and maths. And now, Samira, I always found very interesting for all of the job positions that you see, you normally don't see anything related to a scientist per se. You see like positions such as software developer, programmer, support, etc. But the term scientist in the job position sounds very like another level, very high level. So I would like to ask you, why is it that we call it a scientist? Who is in reality a data scientist, and why is it called that way?
I think they call scientists because they need to, yes, at least to research the methods we will use. Because you are given the task, and in most cases, in very most cases, you don't know what is it and how to work with it, and how to extract data for this task. You don't know how to work the data that you will gather. You don't know, and you need to research how other people worked on almost the same problem, or if not almost the same, but some kind of similar tasks. Or for example, to research maybe 10 years ago somebody mentioned that, oh, we can have some kind of data and we can work like this. Yes, and you just try to find the papers and just try to apply. Yes, and there are a lot of papers without any code, without anything, and you just look at the paper. Okay, I need to implement it. Yes, and in a paper you can see we have 100% accuracy. It's the best method in the world, so we are the best. Yes, and then you try to implement it. Okay, maybe I'm doing something wrong. Yes, and you need to implement your own methods. Yes, your own techniques. You need to try different models, different tools in order to make the model, make the extraction tools more accurate.
In your opinion, what are the main blocks or the main elements about data science? Because let's say there are many, many things like business part, as you said, there is the computer science part, or is the math, but there are maybe some blocks that for you are, okay, these are the basics blocks that you need to know to become a good data scientist.
So, for example, for me, these blocks are the first one, data extraction. In most cases, you don't know how to find the suitable data. Where is the data, how to extract it, and you need some tools for extraction, or you have a lot of photos and somebody needs to label them, or you need to construct some tool. So it's the first main component. The second one is related to data engineering. You need somehow to store. For me, it's some kind of maybe optional component. If you don't have so much data, or you don't need to store it every day, for example, in one database, so you don't need some data engineer, right? But if you work in some place, then you need to store every day's data, like every day you receive 1 million of records and you need somehow to store. So you need a person who will deal with all this data, who will, yes, migrate it from one server to another, migrate the database, merge them, to give the data to other people to work with. The third component is, I think, you have some goal, right? You need this data for some reason. You have...
Exactly.
Yes, and what's depending on your objective, you need to construct some model. Yes, and the first component is the data modeling. For example, your main goal was the image classification. You just made some tool that will extract some data, for example, from one camera, yes, each minute, yes. He will give you a photo. Then you just understand how to store it, where you will store it, and after it you decide, I have the suitable amount of data, and now I can work with what I have for now. And try to construct some baseline models, for example, at the beginning, try to see what is more suitable, what is not so correct to apply in this case, what will perform more accurate. And the fourth step is, for me, is like the visualization of the result.
Okay.
Yes, understand what you have done and what is the result. For example, your question was image classification, and at the end you get the classes of unknown images. It's okay, but sometimes, for example, if you will state one question and you will have another answer, or you cannot answer this question, then maybe something was going wrong.
So just to summarize, you mentioned 4 elements, and these are data extraction, data engineering, data modeling, and visualization. Is that right?
Yes.
Perfect. And now I am interested in your background as a bachelor in maths, and that later on you mentioned that you wanted to develop your statistical knowledge and develop even more complex mechanisms. And also you mentioned that maths are an important part in data science. So my question is more related to the statistics and the relationship between statistics and data science. What is the role of statistics in the field of data science? How do you use them?
I wanted to say not exactly about statistics, but it's about statistics and math analysis or calculus and optimization techniques. They are mostly used in different machine learning models, in different techniques that are applied to the data. For example, if you want to construct some model, if you want to know how it works, why it works so, and how to improve it in case of failure, you need to know what is inside this model. And inside all of these models, just math, just pure math.
Oh.
And the whole math is under these, how can I say, beautiful layers, beautiful, yes, programs in Python, for example. In Python, what can you see? For example, you import some libraries and just stack layers. Import one layer, import second layer, import third, input layer, output layer, and just put the data.
Yeah.
But if you will get not desired result, what you will do? You need to see, you need to analyze what went wrong, how I can improve it. Yes, and to improve it somehow and to understand, you need to know math.
Yeah, Yeah, I believe that it's very important to know everything related to math, especially in this area. And now, in my case, I have seen a lot of job offers, especially during the last year and something. But I have always seen very similar terms like data science, data analytics, and in the past there was another expression that now is less frequent: business intelligence. How do you differentiate these three specific terms, or how would you define them?
Uh, for example, for me, then I see the position for data scientist, it's still unclear for me for what person they are looking for. Yes, for example, they can write, this person should work on the data management, for example, migrate from one server to another and work with big data with clusters and blah, blah, blah. Okay, and in the same role, at another company, you can see, for example, data science, we need data scientists. And you can see deploy neural networks, working with APIs, and you are looking for two data scientist positions, and okay, here mitigate the data, here to deploy the models. Yes, and the data science, it mostly depends on a person, on a company who wants this person, the description of this role. But data analytics analyst is more clear for me, because data analytics is just, how can I say, the intersection of math and statistics with business needs, because the most of financial companies, they are looking for a data analysts, the people who can work with the huge amount of data that change with the time. Yes, and they just need to analyze the prices. Will they be higher tomorrow, or will they less that their threshold today, or something else? Yes, and they just in most cases they use not so complex tools. There are a lot of companies who works only with Microsoft tools like Excel. And then they can analyze a huge amount of data just using the Excel and its predefined functions.
Yeah. Samira, we in the software development world usually talk about the software development life cycle, and it is that you gather all of the requirements, then you go through an analysis, design a solution, then you actually code, test, deploy, and then the maintenance. So is there anything similar in the data science projects? Is there such a thing as a data science life cycle?
Yes, of course, we have some kind of life cycle. And one of the first components is the business understanding. But business understanding in this case means the understanding of the task you are given. You have a task, and from the understanding, you should understand what data you will collect. And after understanding the problem, you have the next step, the data collection. Then you have the step data preparation, then analyzing the data. After analysis of the data, what can you do with the data and something else? You can make a model for your task. Yes, after you will create your model, you should evaluate it. Yes, and after evaluation, for example, in most cases, you should deploy the model, for example, to give it to the user, yes, in order to test it. User will get your model tested by himself, and then come to you. And if he has any problems, you can again go to the first step of business understanding to understand what was wrong. Maybe you with the customer had different ideas.
So is the user the one who tests the model? It's not you as a developer, let's say.
You have two stages of testing. One of the your stage, you create the model and then you evaluate it, how it works. Yes, but it's your understanding from the beginning because, for example, you are the technical leader of your team, yes, and you had these requirements, yes, like in software development. And you just tell your team you did everything and then you tested it. For you it's okay because you tested like from the data scientist's perspective this model, and it performs good because this model is accurate. But for user, it could be something different. For example, he took it, but I wanted not to have the rectangles. Yes, for example, I wanted to see all signs in the photos. And I didn't want to have a rectangles. I wanted to have stars. And you
Yeah.
just, okay, just stars and that's it. And you just change everything to the stars and that's it. Or maybe user want to, I want to have a web application, then I will store my data, then I will upload my data, and then I will have this beautiful graph, for example. It's just the design choice of the user or interface choice, something like this.
And in your case, what kind of interesting projects you have seen recently with data science? Because you have told us a lot of, let's say, cool ideas, and Xavier has shared with us about others, but maybe you know some new research or new projects that you think these kind of projects in data science are something that we would like to see.
Yes, for me, there are a lot of interesting projects related to the self-driving cars or self-driving something, not only cars or rovers that can deliver something, yes. And for me, it's really interesting because in small, good developed cities, it is one story. It's more simpler, for example, to do it in a small area. But if you want to extend this, how you can deal with problems that occur, yes, in each cases, how you will, how can I say, mix people with these self-driving things. That
Yeah.
in one case you have human with unpredictable behavior, and in other case you have something that you can something which behavior you can just correct somehow. Yes, and this interaction is very interesting for me from the ethics side, from the technical side also, because there are a lot of methods, and for me they're just very complex and very excited.
Yes, these projects, self-driving cars and drones and automats, it's still unbelievable for me. And now that we are in the topic of the applications, and we have also spoken a little bit about the jobs, I would like to ask you, how well paid are the jobs in data science, and what is the demand in the market nowadays? Because at least I can see it from my perspective as a software developer. I can see that in the current times, IT professionals are in high demand, and that's why also the jobs are very well paid. Is it the same case in data science?
Uh, it's also the same, but as I think the market is full of specialists, of more or less good specialists, yes, and if you want to have a good paid, well paid work for data science, you need to know a lot. You need to be experienced with a lot of things, yes? Because as I told before, you can see we're looking for data scientists. And for example, a few days ago, I saw their job position. We're looking for data scientists. 6+ years of experience in Python, 6+ years of experience in C++. Yes, the degree in mathematics or computer science, yes, experience with Python libraries, experience with some kind of model deployment, how to do it, or working with other tools, working with tools for virtualization. And there is the long list of what you should do and what experience you need.
Yeah.
Yes, and of course, not most, but a lot of companies are looking for a data scientist with knowledge of C++ because there are, how can I say, enough number of libraries for Python are written in C++. Yes, and you need somehow, for example, change them or to do something to your own needs, to your own goals. And in some cases, as we know, the Python is very slow, and in some cases you just try to make your model, try to deploy, and if you have a lot of data, a lot of information, you just will die or try to wait for a lot of hours or days or something like this. For Python, it's okay if you will train the model for 3 days.
3 days. Wow.
Yes, you will just wait for 3 days. You will just leave your laptop at work and just go home and have a rest, and your model will train the whole 3 days. Yes, and in some cases, the companies want to improve the quality, improve the speed, and they suggest to migrate this model to C++. In case of limits. Yes, and how they paid? For example, per month, it can be some thousands of dollars per month. It's okay. For good data scientists. And for example, if you will go to financial company as a junior analyst, but after passing, for example, 8 interviews in math, in Python, and in whatever they want, psychological test, you can be paid about $5,000 as a junior analyst.
Junior. Wow.
Junior analyst.
Wow. And let's say now that we have been speaking about the jobs, how do you think that data science influenced the development of the vaccines during this pandemic? Do you think that there was any involvement in any way, or it wasn't involved?
During the pandemic, I know that a lot of companies, a lot of researchers, they were interested in applying machine learning and statistical techniques to know how the pandemic will go, how many ill people we will have, or how many deaths we will have, somehow to predict these numbers. Yes, also I saw several articles related to this topic. Yes, and as I know, for example, in a lot of conferences, you can see, for example, topics like applying some models related to the COVID-19. Yes,
Yeah.
some new tasks.
So, and you have mentioned that there were some initiatives to apply machine learning to predict the development of the pandemics. However, from my perspective, this seems to be only a rather informative information that, okay, we know how it will develop, but like this is like, is this still not doing anything about it? So my question is if you know like how can companies or even governments could have used data science differently, like apart from predicting the development of the pandemics?
In case, for example, the pandemic situation, the prediction, it can help. It can help, for example, you predict that in this region there will be a lot of ill people. So at first you will get the vaccine to this region. You will put a lot of, for example, medical employees to this region, trying to somehow to improve the situation in this region.
And in your case, how would you define machine learning to the regular people? Because it can be a topic.
Machine learning. Then you try to make your electronic device, your laptop, for example, or your mobile phone, to behave in a way you want, but you will not program it by each step. For example, you want your phone to classify the images, but of course you cannot classify all images in the world. You just take some images, you will teach your model on these images, and then just let it go to the world, just try to learn different things, try to guess, and this combination I think can explain the machine learning.
Yes, it makes sense to me. And you know, Samira, just a couple of weeks ago, we interviewed a professional in artificial intelligence, and we also talk about this topic of machine learning. He introduced us also to the topic of deep learning, something as a subset of machine learning. So I would also like to ask you, what are the most common types of machine learning?
The common types of machine learning is supervised learning, unsupervised learning, and also semi-supervised learning and reinforcement learning.
And is this somehow related to the concept of deep learning?
Yes. In each cases, you can have the deep learning, the deep complex structures, the complex models in each case.
But how would you define the difference between machine learning and deep learning? What will be a difference for you?
For me, if I will tell it by the simple words, it's just the machine learning is something that at the surface, that some simple models that you can construct. That, for example, you have some things that called artificial intelligence for everybody. That's some models that can be understandable by a lot of people, yes, and you can teach these models to everybody. And deep learning for me is something that under the surface, that is lying more deeper, that requires more understanding of concepts of machine learning. And the models of deep learning, they are more complex.
I see. So now, Samira, let's go a bit back to the concepts you introduced about the types of machine learning. So you mentioned that there's like supervised, unsupervised, and what was the other one? Reinforced, if I'm not wrong.
Yes, reinforcement.
Could you please explain us what are these types of learning specifically?
Yes, of course. Supervised learning, when you have your data and you have the answers for your questions. For example, again, image classification. You have image and you have, for example, the name of the object in this image. For example, you have the images of animals, and for each image you have this cat, dog, the third image, parrot. And for each image you have the label. This name is it's called label. It's the supervised learning because you can train on it, test on it, and you don't need to do with the data anything. You just have the input and the output. You can have the unsupervised learning. For example, you have a lot of articles, news articles, for example, and you just try to make categories out of this news, but you don't know what categories will appear. And then after the categorization, you understand, I see, I have this category of news related to sport, these categories of news related to fashion, and other ones. In this case, you don't have labels. You just have the articles and that's it. You don't know the category at the beginning. You also can have the semi-supervised. Some researchers use this term, semi-supervised. For example, in case when you have some data with labels and some data without labels, and you just try to apply some techniques how to work with this mixed data. For example, classification is our supervised learning because it requires the image and the label. And clusterization, it's unsupervised learning because it requires only the articles and it will make categories by itself. And also we have reinforcement learning where we don't have any desired, how can I say, we don't have the specific steps. For example, you have drone, right? And you will not take to give the drone all coordinates. For example, for 5 meters, you will go like this, then in the 6 meter, you will go like that, then like this. And because the conditions will change every time, depending on the way it will go, depending on the weather, it will go, yes. And of course, it will change. But you will have some cases there, the desired behavior. The desired behavior for you, this drone will not go straight to the tree because it will damage itself. So for you, it will be not desired behavior. And you will, for example, you will give it points for the good behavior. For example, if it will see the tree and it will go near the tree, not exactly to this tree, and you will go some points for it. And for example, if it will go under the house, you will also give some points. For example, you're a good boy, you have a reward. But in the cases if it will go straightly to the building, you will just, no, God, please. And you will just subtract the points you gave.
And in our times, we are constantly developing new algorithms. But something that previously Xavier shared with us is that he believes that we need to create new algorithms, especially that can, let's say, make the things more efficient and reduce those 3 days that you were telling us with Python. Do you believe that we need a similar approach to create new algorithms more than just new libraries?
As I think new algorithms, they appear every day, every time, because the most algorithms, they are not mathematically proven. Because a lot of cases just they tried empirically This method didn't work for us, but this method works, so let's use it. And there is no any mathematics behind why it worked so. And you just try, in your case, for example, you have just slightly different data and you try to apply the best model and it didn't work so well for you. You just change something in it and you have, in general, the new model because you already changed something in it. And so it's new. It's already a new model.
Yeah. Okay. That sounds like not so professional if the algorithms are not mathematically proved. They're rather, let's say, like an attempt and error, you know. But it is as it is. And I think that I have seen in the cloud that the cloud already supports some of the algorithms. And I would like to ask you, do you think that the cloud has supported the development of data science or the spreading of data science, let's say?
Yes, as I will talk about myself.
Yeah.
I'm not using my own laptop to test some models. For example, I want to see how one or another model will work. Yes, and I use just the platform, the Google Colab. They give the virtual machine for you. Then where you can run with a good interface, with a Python, yes, and with Ubuntu, yes, with Ubuntu, and where you can run everything you want. At the first time, they gave us the video card also, and you can just use more power in your machines. But now they understand the how can I say, the good times passed, and you need to have a pro version to use the video cards, but you can still use this cloud platform with their resources to just build and test your models without installing anything on your laptop. Just to work in the cloud in this virtual machine.
Okay. And you mentioned, Samira, that you used the Google Cloud app, and it has the benefit that you can use it without installing anything on your PC. You just like upload your models, and that's it. And it seems to me that the cloud, it has brought this benefit that you don't need to install anything, you don't need to prepare anything. So probably more and more people will be joining, and it will be more spread around the world. But what do you think that is the greatest limitation in the development of data science?
The limitation of development of data science as a, how can I say, as the area or as a model deployment?
As an area, I will say.
As an area. The limitation, it's difficult to understand, for example, who is the data scientist for a lot of people, yes? And now, some time ago, they were thinking about the mathematicians, about statisticians, and some people related to math. But if you spend, for example, 4 years for the bachelor in maths and then your master's in maths, it's already 6 years without experience in software development. But then you will go to the industry and you need to have some kind of experience in the development. Okay, But if you have your degree in software development and when your master's in software development and you go to the industry, you can develop, but you have no idea about the concept behind the mathematical models. So the big limitation is that the good software developers, the really good software developers, they have this lack of mathematical knowledge. Because they can do a lot of good stuff. Because for me, I cannot, for example, I don't know a lot of things related to the software development itself. How to develop big, for example, infrastructure and something like this, yes? And in order to expand your model, you need to know how to work with the software development stuff, how to work with the servers, how to split your model in order to work on different devices, on different servers, and etc. And you need to be experienced in software development, software engineering. But we have this limitation, that mathematicians, they don't know how to develop the software, and we have the software developers who is not experienced in mathematics.
Yeah, I understand that because I face it. Once I wanted to build some machine learning models, and in my experience, it was pretty tough in the beginning. I read some books for dummies that were for dummies, and coming back to the point, you started with the nice things about machine learning. Then there was a massive amount of algorithms that you were no idea. And this was a book from a famous university, and it was how to move forward. And when I asked my friends who work in the area, they were like, you need to know math. Okay, and what should I learn about math? You need to know math. It was like it's pretty hard to get into it. And as I said, I was doing some of these experiments about machine learning. And another limitation that I saw, it was about the labeling. And for example, when you are trying to label in data, it's like a very tedious task in my experience. It was sometimes you needed to spend like, yeah, there are like 50 images and I know 100 images, 500 images. And I was completely getting mad because of that nice part. Do you know any auto labeling tool? Because really, I would like to have one of them and to minimize my crazy experiences.
Oh, no, honestly, saying I have no experience with auto tools, but I don't know. In my cases, I didn't use it. But if you want to, if you want someone to label it, you can use crowdsourcing platforms. Yes. I don't know, maybe they are more popular in Europe or in USA, but I know some in Russia, yes, from a big company. They use this crowdsourcing platform. They just pay people, just non-technical people, to label the data, for example, or they just need to extract some data from the sites, from the websites. They just give them list of sites and people just go. They are paid for this work, but yes, of course you pay not so much, and you just, as they told you, they just benefit from this crowdsourcing. They don't need to spend a huge amount of time for labeling and something like this.
Yeah. Now, you have mentioned that you have used the Google Cloud app for testing your models. What other tools do you use for your work as a data scientist?
I'm using a lot of Python libraries, yes, and in some cases you have just the binary version of this library, and in documentation you see if you want to deploy the model with this library, just install this and compile it by yourself. Okay, and you just try to do that. Of course, I'm using some, how can I say? I will say tools that they call PyTorch, Keras, that will help you to make deep learning models. They are like modules that can be used with a Python, yes. And one of the tools that I'm using is Docker. Then you want to make an image out of your application because I really don't know in some cases what I can do with my Python script.
Yes.
Because what I have a script, of course, and it's beautiful, but what can I do? It's more applicable if you want to deploy your script into some big system, for example, to the backend, and the whole backend is on Java, for example, and you just with your Python script, just trying to say hello. Yes, and in some cases you just try to use whatever you want depending on the goals. In some cases, I did the web applications, yes, or Telegram bots. It's also okay. For web application, I use the Google API. My application was working with the Google Drive folders. So these tools.
I have a follow-up question, and it's something that caught my attention. I am a Java developer myself, so I have been working in Java for more than 6 years. And when you mentioned that you used your Python application to say hello to the Java backend, how does this work? Like, what information are you trying to get, or what kind of communication does it occur between these two systems?
For example, in order not to make everything like a hell in general, because if you work Python, if you want the Python to work with Java, you need to use a library named GPython. Yes, it's some kind of mixed Java and Python, and I was looking at it just, okay, it looks like Java with the elements of Python. It was awful for me because honestly, I don't like Java. Yes, I was experienced for 1 year on Java, yes, and the big project on Java was the game, the snake, simple snake. Yes, and that's it. And for me, it was so difficult. Yes, I went to after C++. Yes, I have the evolution, the C++, Java, and then Python. And we decided with Xavier, the first time I asked him how I can deploy my favorite, my beautiful script into the backend, and he just asked me, try to rewrite on Java. Thank you. No, I will not do it. Of course. So we decided not to mix them. And he just stores everything in a database, and my script takes every information it needs from the database and then works on the same server, make the computation, and then write what it did to the database. And it works as a separate image, Docker image.
And now that we have been speaking about Java, like how about the tools that you use, the question is how, if I wanted to start in data science, what will be your advice? Because, you know, you told us, I become a software developer and I have no idea about math. And then I go to the other extreme, then I'm great in math, but I am a terrible software developer. So what would be your advice? How can I get started? Do you have any book, any training, anything that you could advise us? Maybe you create your own trainings also.
Unfortunately, I haven't created my own training tools, but if you want to start your career in data science, you can just start with the courses like Introduction to Machine Learning. Some good courses in Coursera from deeplearning.ai from Andrew and G. Yes, they're very good. They're very, in some cases, simple, and also some statistics. Yes, some calculus, linear algebra, statistics, and optimization. Just take any courses. Take some basics from these areas. Yes, and of course, if you want to do something in Python course. But Python, it's to start. It's how can I say, the easiest part to start with. You just to take Python and without data types, just trying to do something. Yes, and then you will understand how to work with it, what you need to do, what data types you need to work with the models. That will be some differences. So you will see.
So far, it seems to me that a data science needs to know like a lot of things: calculus, linear algebra, Python, software development. It's a lot of stuff in order to get started. But now, Zamira, as we usually do in Cyber Prophets, we try to prophesize what's going to happen in the next decade. So my first question regarding the future of data science is, how do you visualize the impact of data science in the next decade?
About the impact in the next decade, really, I don't know what will be, because the situation now, the world situation is very, how can I say, unpredictable, and you really don't know how we will work. There may be 2 years, two nearest years, but the evolution of data science, of its application, it grows without dependency on the situation, and people are working hard, and you see that data science now is everywhere in each application. As you know, for example, for the banks, they're just trying to make applications like you are going to the bank stage, and you don't need your card, you just need your face. It will read the biometrics from your face or from your fingers, and you just will work with your card. Also, something like the self-doable things, like we already have some drones, some kind of this, and and I think that something will be used for delivery, to deliver some goods. And I think that this direction of the full automatization will go through.
And previously, as we spoke, the cloud computer really empowered the development of data science. Now you can see in the news or new solutions that are related to quantum computing. Do you think that this is going to empower more data science to go into a new level?
Maybe not in a new level, but the all limitations that we have for now will not appear further, because now we have some limitation. For example, we don't have the enough RAM, enough memory of the video card, enough memory itself for storing such amount of data, and maybe the computational power of quantum computer will help us to deal with these problems. And we will not split our models into different ones to train or test something. We will use just the big whole model with the big whole data set and just try to compute it. So we will deal with the current limitations.
These are very, let's say, innovative applications that you have mentioned. I will be waiting for the time to see how data science will read my biometrics and actually make things easier when I go to the bank, because here in Europe it's a lot of bureaucracy and it's quite hard. So thank you very much, Zamira. Thanks for your time. You have really enlightened me and increased my knowledge about data science today. And now it is even clearer for me what is the difference between a data scientist and why is it called a scientist, actually. Thank you very much for your participation.
Thank you very much, guys, for inviting me. It was really interesting. So thank you.
Thank you. And Federico, do you have any last words?
Thank you very much, Samira, for bringing us some light to the darkness that many of us were living in the data science world. Hopefully, our audience is gonna follow us, will like your new ideas, and we will see you soon with new projects. Hopefully, we'll see your new paper or your new drone flying over us, changing our lives.
Yes. Remember, in order to become a data science, you have to combine both worlds, the best of maths and the best of software development. We are Cyber Prophets. Thanks for watching us. See you in the next episode.